Hey, it's Miss Menace. Go ahead and do your warm-up. 1 through 3, find the value of each variable, is what you already know. Then fill in the blank 4 and 5. Okay, go ahead and try that. Okay, so number 1, you have 130 degrees, then x. They make a straight line, so just 180 minus 130 should be 50 is x. Okay, for 2, straight line again, so 180 degrees. This is 90, so what's left is 90 degrees. So z is 90. Okay, number 3 is a little different. We have 90 degrees over here. So this side has to be 90 because of 180 minus 90 is 90. And then from the 90, y is left over, but you have 55, so subtract it. We'll get y is 35. Okay, perpendicular lines are 2 lines that intersect to form right angles. Number 5, an angle is formed by 2 rays with the same endpoint. The endpoint is called the vertex of the angle. Okay, hopefully you had all those right. Alright, let's talk about some new angles we're going to learn today. 4 different kinds. Vertical angles. Okay, so they are opposite. 3 and 4 are vertical angles. 1 and 2 are vertical angles, okay? Adjacent angles. Adjacent, just think about what that means. Touching. So any angles that touch. Okay, so 1 and 2 are adjacent angles. 3 and 4 are adjacent. It has nothing to do with the measures, just if they're touching. Okay? Complementary angles, they add up to 90 degrees. So any numbers that add up to 90 degrees, they don't have to be touching. Okay? In this case, 1 and 2 are touching ones. So those would be complementary adjacent angles. And then A and B are complementary, but they're not touching. So A and B are complementary too. Those are non-adjacent complementary angles. Okay, then supplementary angles, same idea as complementary, except for you have 180 degrees for their sum. Okay, so here's adjacent ones, 3 and 4. And then this 75 degrees, 105 degrees, those are also supplementary but not adjacent. Okay, so they don't have to be touching to be complementary or supplementary. Got it? Okay. So let's go ahead and fill in our blanks down here from word vocab. So you can use deductive reasoning to show that a conjecture is true. The set of steps you take is called a proof. The statement that you prove true is a theorem. Theorem. We're going to talk about some of those today. Okay, number 6. A paragraph proof is written as sentences in a paragraph. Okay, so today we're going to take proofs like what we learned in 2-4, where we had the work and then the justification, and we're going to put it together in a paragraph to explain what's going on. Alright, so we'll talk more about that. Let's go to the next page. Okay. So, identifying angle pairs. In the diagram, identify pairs of number angles that are related as follows. So we're going to find some complementary angles, supplementary angles, and some vertical angles. Okay, complementary means they have to add up to 90 degrees. Right, so that's easy to see. Over here, 90 degrees. 2 and 3, those are complementary. Okay? Angle 2 and angle 3. If you see another one, there is another pair, but we will talk about that once we talked about vertical, okay? So let's look at supplementary. That has to equal 180 degrees. So anything that adds up to a straight line. Here's one. Okay. But look, are there two angles that add up to this line on the top? No, there's three. 1, 2, 3 to give you 180. There's no set of supplementary angles here. They have to be two angles together. Okay, however, if you look below the line, angle 4 and angle 5, those are supplementary. Okay? Alright, let's think of, is there another line going on here? Well, yeah, there is. Here's a straight line. Are there two angles that add up to 180 there, supplementary? Yeah, angle 3 and angle 4. Okay? So as long as you didn't say angle 1, 2, and 3 are supplementary, then you're good, because you can't have three supplementary angles when it says pairs. Okay, so let's talk about vertical angles. So those are the ones kind of across your vertex. 5, 3. Okay, those are vertical angles for sure. So do you see any more? Going straight across the vertex so they're touching the same vertex. I don't see any that are exactly the same angle width on both sides. So that's the only set of vertical angles, okay? But since we know that angle 3 and angle 5 are vertical, they're equal. We'll talk more about that later, but if you want to say that angle 2 and angle 5 are complementary, you can also say that. Because if you did find their angle measures, they would add up to 90 degrees. So just add that to the list. Okay? Alright, so let's look at this other example one. We have a picture of a road going off into a mountain with some clouds. Sorry, there we go. Okay, so example one. Name two pairs of adjacent angles in the photo below. Two pairs, so that means I need two sets of two pairs of angles. Okay, I'm just going to start with the leftmost. Here's AFB. What's its adjacent angle? BFC. Okay, so angle AFB and angle BFC. Okay, those are definitely adjacent, they're touching. Alright, let's get another set going. Okay, how about this one, CFD? Which one does it touch? Well, it touches two angles, okay. So DFE, that's one choice. Sorry, angle. Okay, or you could also say CFD touching BFC. Okay? So those are your three pairs of adjacent angles. All the adjacent angles shown. Okay? If you want to get technical, you could say angle EFA with angle AFB, because technically angle EFA is an angle, it's a straight line. It's a 180 degrees angle, okay? So you could say angle EFA and angle, see where they touch, BFA. Okay, so on and so forth. There's plenty of different examples. Okay, just showing you that straight line is definitely one you can choose from. Okay, so B, I'm not really sure what went on there. These should be angle signs, sorry. Okay, so let's look at it. If measure of angle EFD is 27, where's EFD? Over here. Okay, find measure of angle AFD. Okay? Measure of angle AFD. When you're using one diagram to answer multiple problems, I would definitely use some highlighters so I know what I'm talking about. And that wasn't even right, sorry. Angle AFD is this whole big one. Okay? So we have this chunk and then the blue chunk. Okay? So let's figure out what those measures are. Well, first of all, I have to think about the fact that each angle adds up to 180 degrees because it's a straight line. Okay, so let's write that out. Angle EFD, or measure, plus measure of angle AFD equals the whole 180 degrees. Okay, so now let's plug in what we know for each. EFD is 27 right there. AFD, I don't know, so let's just leave it. That's what we're going to solve for. Equals 180. Okay, then subtract 27 from both sides. Treat it like an equation. Measure of angle AFD equals 153. Okay, and that's what it asks for. Find measure of angle AFD. Well, it's right there. Okay, so looking at this diagram, there were some things we could conclude. However, let's look below and think about what we can't conclude based on a diagram. Okay, so it's important that you don't just assume that these things are true. I think it'll make more sense once we talk more about it on the next page, okay? But let's just go through it. Whether you draw a diagram or use a given diagram, you can make some conclusions directly from the diagrams. So, what it's okay to say right away are adjacent angles. If they're touching, they're adjacent. Adjacent supplementary angles. Remember, we can say 180 degrees if it's a straight line. Always, you can just assume it. Vertical angles, okay, so when they go across each other in the vertex. You can say that those angles are congruent, or that something's going on there, right? But let's talk about here below, because that's what's most important. You cannot just assume these things here. You can't just say angles or segments are congruent randomly. AB is congruent to BC just because I think it looks like it. No. Alright? An angle is a right angle. You can't conclude that. Even if it looks like it goes like this. Okay? You can't conclude it's a right angle until it has its mark. Any two lines that are parallel or perpendicular. You can't just assume it. Again, it will tell you it's parallel, or if it's perpendicular, it would have to have the little 90-degree symbol. Do not assume, because it makes it you know what out of you and me. Alright? Okay, so let's look at the next diagram here. Flip the page. Okay, and let's figure out what we can conclude based on the markings and what we can't conclude. Okay, so first of all, what you can't conclude is, oh, I think angle 3 is 90 degrees because it looks like it. No, you can't say that. I think angle 2 is congruent to angle 4 because it looks like it. No, you cannot say that, okay? But something you could say is that angle 2 and angle 1 are congruent because they have a mark right there. Any angle that has one dash through it like that is going to be equal to any other angle that has one dash through it. Okay, so let's put down the first bullet here. Angle 1 is congruent with angle 2. Hey. Sorry. My dog's having an attack. Okay. So, Adjacent angles, remember we said you can conclude that. Here, they're touching. Adjacent, all that has to do for touching. Angle 1 and angle 2, for example, are adjacent angles. Here's another one, 2 and 3, 3 and 4, 4 and 5. They're all adjacent. Okay, so let's read this next one though. Blank and blank, for example, are adjacent supplementary angles. So can you find adjacent supplementary angles? Well, here's a line going across, right? On the top, we can't find a pair, and on the bottom we can. 1 and 5, those are adjacent and supplementary because they add up to 180, your straight line. Okay, so you can put that angle 1 and angle 5, or measure of angle 1 plus measure of angle 5 equals 180. Okay, cool. Another straight line's here. So that means you can use 4 and 5. But you can't use this 1, 2, 3. Because those aren't a set of pair of angles. Okay. Okay. So next bulletin or bullets, we want vertical angles. Okay, so the ones going across the vertex here, 1 and 4. So angle 1 and angle 4 are vertical angles. Okay, so all of this you conclude from the diagram. Okay, so let's look at example 2. Maybe some examples of what you can't conclude. There it is. Okay. Answer the question. Can you make each conclusion from the information in the diagram? Explain. Alright, so let's look at it. TW is congruent to WB. Here's TW. Here's WB. Okay. Are they congruent? Well, yeah, they definitely are, because what's going through them? The mark, the dash. Right? So yes, they are marked. Okay? What you can't do is say PW is congruent to WQ, because they do not have a mark through them. Even though it looks like it might be congruent, you cannot assume. So here, no, they are not marked. Okay? If they had dashes on the other side and they were the same, then you can say yes. Okay? C. TB is perpendicular to PQ, meaning it would cross it at a 90-degree angle. Yes, it looks like it, but can I assume it? No. Can I make the conclusion from the diagram? No. It would have the little perpendicular mark on it, right? It would do that, okay? So, let's also see TB bisects PQ. TB bisects PQ. Okay, well it's crossing PQ, but a bisector means it's the same length on either side where they intersect. So at their point of intersection, W, it has to be the same on both sides. That would make this a bisector of PQ. Alright? That's not the case. We can't just assume it, because we don't have markings here and here. Don't assume there's markings there, okay? So again, this is no. Okay, but E, let's look at that. W is the midpoint of TB. W is the midpoint of TB. Here's T, there's V, and I already circled W, okay? If it was the midpoint, that means on either side of W, the segments are the same. They're congruent, yes. TW is congruent to WB based on the markings, so we can say yes. So by this, I can conclude that for sure. Okay? Okay, so let's move on to investigating vertical angles. I kind of already told you what's going to happen, what we're going to conclude here. But let's look at it. So draw two intersecting lines, number the angles shown. Here we go. 1, 2, 3, 4. Both the sides of angle 1 onto angle 2. Okay, that means I would have to totally flip my paper like this. Alright, let's switch that around. Try to fold the sides of angle 1 onto angle 2. It's kind of hard to see, but if I were to do that, my angle would go like this, which is exactly like angle 1. Okay, that's cool. Maybe you'll be able to see this one better. Fold the sides of angle 3 onto angle 4. Okay, and if you look closely, you can see if I did that and folded at the vertex, they would overlap and it would look the same. Okay, so make a conjecture about vertical angles. Alright, let's see. Angle 1, fill in the blank to angle 2. Alright, angle 3, fill in the blank, angle 4. Thinking about the fact that we could fold the paper and get the same exact angle out, right? Well, what goes in the blank is that they're congruent. All vertical angles are congruent. Okay, so 1 and 2 are the same measure. Also 3 and 4 are the same measure. Okay? Okay, so that's your investigation. Let's look at what comes from this. It's a theorem. Next page. Okay, you can use deductive reasoning to show that a conjecture is true. The set of steps you take is called a proof, are called a proof. The statement that you prove true is a theorem. We kind of already talked about that. The investigation above, or on the previous page, leads to a conjecture that becomes the following theorem. Vertical angles theorem. Here it is. All vertical angles are congruent. 1 is congruent to 2, 3 is congruent to 4. We just figured that out. So from now on, you can use that as a theorem. You don't have to prove it. You don't have to try to, add these angles up, whatever. You can just say it. Vertical angles are congruent. Okay? So let's look here. We're going to prove this theorem. We're going to prove this theorem. In the proof of the theorem, you're given a list that shows you what you know from the hypothesis of the theorem. Okay? Then you prove the conclusion of the theorem. And a diagram hopefully is given to you so you can record the information visually. Okay, so here's a given, you will be given a proof. So that's what you want to try to conclude at the end. Okay, sometimes you can make a diagram, or sometimes you have a blank diagram, or sometimes you have a fully labeled, shown, marked diagram, which is awesome. Okay? So, let's talk about our next kind of proof we're going to learn. There are many forms of proofs. A paragraph proof is written as sentences in a paragraph. Okay, here's a paragraph proof of Theorem 2.1. We're going to do that. So, on the last section we had the little table where you said what you know and your justification, right? Now we're going to write it all together in a paragraph. So, you can kind of choose unless it states what to do. Like in this case, it says write a paragraph proof. For the most part, you can choose which way you like better. Okay, I kind of like them both. It's really up to you. So let's look at what's going on here. We're given that angle 1 and angle 2 are vertical angles. Let's mark it on the diagram. We're going to give them the same exact dash. Okay? They're vertical angles. We want to prove that this dash is true. Angle 1 is congruent to angle 2. That's what we're going to prove. Okay, so let's do it. Remember what I told you. If you have an angle or you have a line segment, usually your first step is going to be using the addition postulate. It's no different here. So, firstly, write this with me. Angle, addition, postulate. Okay, we're going to say measure of angle 1 plus measure of angle 3 is 180 degrees. Okay, so let's say that. Measure of angle 1 plus measure of angle 3 is 180 degrees. Or you can say 180. Okay? Now let's flip it around. Also by the angle addition postulate, we can say measure of angle 2 plus measure of angle 3 is 180 degrees. Okay, and we want to do this, you'll see later, but we want to have them both equal to the same number. So also by angle addition postulate, measure of angle 2 plus measure of angle 3 equals 180 degrees. Okay? They each separately create a straight line. So we're trying to prove here still that angle 1 is congruent to angle 2. These are equal. If something is equal, I can substitute it out, right? So I can switch this 180 out for this, measure of angle 2 plus measure of angle 3. Okay, let me highlight that for you. By substitution, we're going to take this measure of angle 2 plus measure of angle 3, switch it with 180 because it equals 180. Okay, you need to understand that you can do that. So let's do that now. By substitution, measure of angle, let's write this one first, 1 plus measure of angle 3 equals, now let's write what we substitute, measure of angle 2, I'm writing the purple, plus measure of angle 3. Okay, so we just switch them out because they're equal, right? Okay, cool. So, what are we going to do next? Well, we have measure of angle 3 and measure of angle 3 on both sides, so we want to get rid of it. Okay? So, subtract measure of angle 3 from both sides to get, okay, so if I subtracted, oops, they would go away, just pretend that happened. To get measure of angle 1 equals measure of angle 2, right? They're gone. Okay, so therefore, if the measures are the same, they're congruent. Angle 1 is congruent to angle 2. Okay, and we're done with our proof. I know it's really weird, but when we're done with our proof, you fill in your box. Okay, you're going to learn a lot of proof language. Therefore, done. So you can do that if you want, or just put a period, so I know you're done. Either way, it's all good. Okay, critical thinking. Does the size of the angle, do the size of the angles in the diagram affect the proof? Would the proof change if angle 1 and angle 2 were acute rather than obtuse? Explain. Okay, so let's look here. Would it change if you use different angle measures? Well, if I have angle 3 here and angle 4, let's think about how I could do a proof there. I'm not going to do it, but let's just think about. I could say by the angle addition postulate, angle 1 plus angle 4 is 180 degrees. And by the same, I could say angle 3 plus angle 1 is 180 degrees. So same ideas here, just switching them out. Okay, then I could subtract angle 1 from both sides and get angle 3 is congruent to angle 4. So I can go through the same exact proof, and no, it does not matter how big they are, whether they're acute, obtuse, whatever it is, okay? So no, it doesn't matter. And if you want to think about it, I could go through and do the same proof, just with different angles, right? Okay, so stay with me, not too much more. Next page. Last page of really doing work. The next page are just kind of overviews of theorems. So you can do it, alright? Using the vertical angle theorem. Love that the vertical angles is a theorem. Trust me, it makes your life way easier. Because I can just look at this and say, boom, they're vertical. That means they're equal, okay? If you couldn't see, sorry, I meant to do that first. This is 4x. This is 3x plus 35. Okay? Okay, so vertical angles is really awesome, just to be able to say that they're congruent. And that's what they did, find the value of x, alright? So I'm going to set them equal to each other. 4x equals 3x plus 35. How'd they go from here to here? They subtracted 3x from both sides. Okay? That was it. So, let's do this. Find the measures of the labeled pair of vertical angles in the diagram above. Alright, so your vertical angles are 4x and 3x plus 35. So let's just see if it works. Well, they got x equals 35. Let's plug that in for x. 4 times 35. Do that in your calculator if you don't know how to get it. Okay, that's 140. I better be getting the same thing on the other side. Let's just double check. 3 times 35 plus 35. Okay, that would give me 105 plus 35. And yep, that's definitely 140. Okay, so find the measures of the angles. They're 140. That's my answer. Okay, it didn't say prove it. It didn't say justify. Whatever. We just did it. Read what the question's asking. Don't do more than you have to. Okay? Here, find the measures of the other pair of vertical angles. Oh, okay. So let's think about adjacent supplementary angles. Touching supplementary angles. Okay, so this angle here plus your smaller angle, they're going to give you 180 because they lie on a straight line, right? Okay, so let's label this angle 1. Angle 1. Just so we don't have to randomly say the blue angle, okay? This is angle 1. So let's use angle addition postulate and label this angle 2. Okay, so measure of angle 1 plus measure of angle 2 equals 180. They lie on a straight line. They're supplementary, however you want to say it. And fill in. Well, we know measure of angle 1 is 140. We already found that right here. Plus measure of angle 2 equals 180. Okay, and use your subtraction skills to get measure of angle 2 equals 40. Did I answer the question? Yes, I did. Find the measure of the other pair. Okay, this one's 40. The cross vertical one's 40. You could do the same exact steps to prove that one too. If you chose to do it that way, it's fine. Okay, so check to see that adjacent angles are supplementary. Okay, well that's kind of easy, but we had only 1 to substitute before, now we have a measure of angle 2 to substitute. Okay. So, measure of angle 1, let's use the same diagram, plus measure of angle 2 equals 180. Let's see, measure of angle 1 is 140. Measure of angle 2 is 40. Well, that equals 180. So I get 180 equals 180. And therefore, angle 1 and angle 2 are supplementary. Okay? And I want to point out that I labeled angle 1 and angle 2 on my own. You can do that if you make it very, very clear. Okay? It helps me to label angle 1 and angle 2 and name them. As long as you show it in your diagram, make it very clear so I'm not like, what angle are you talking about? You can do that, that's fine. Okay, cool. So, let's look at congruent supplements theorem. Okay, if two angles are supplements of the same angle, or congruent angles, then the two angles are congruent. Okay, the same goes for complementary. So supplements, 180. Alright, so let's look at an example. Angle 1 and angle 2 are supplementary. So this angle plus this angle is 180 degrees, right? Angle 3 and angle 2 are supplementary. Angle 3 and angle 2 are supplementary. From here, prove that angle 1 is congruent to angle 3. Okay, so I want to say, is angle 1 congruent to angle 3? You may think you know that, based on the way it looks. Okay, cool, but let's prove it. So we're going to use a paragraph proof again to prove this. Okay, let's start. By definition of supplementary angles, measure of angle 1 plus measure of angle 2 equals 180. Okay, so 180 from there. I'm going to say the same exact sentence, but with angle 3 and angle 2. Okay, then like before, we're going to use substitution to switch them out. So next sentence, by definition of supplementary angles, measure of angle 3 plus measure of angle 2 equals 180. From here, you should be able to look at the notes on the previous page and do this proof. Okay, so what we did was measure of angle 3 plus measure of angle 2 equals 180. We're going to use substitution to switch them out. Okay, so let's do that. So, by substitution, we're switching the purples. Measure of angle 1 plus measure of angle 2 equals measure of angle 3 plus measure of angle 2. Okay, now measure of angle 2 is on both sides. Let's get rid of it by subtracting measure of angle 2 from both sides. I conclude that, okay, pretend I get rid of them, which I did, but pretend I got rid of them there. Measure of angle 1 equals measure of angle 3. Alright, turn that period into a therefore, because if the measures are the same, angle 1 is congruent to angle 3. Okay, and that's what I wanted to prove, so I'm done. That's what I wanted to prove. That's what I have at the end. That's when I know I'm done. I can't stop here. I have to go on to congruency. The more you practice this, the more you'll get better at it, promise. Okay. So, same exact thing that we were talking about with supplementary angles goes for complementary angles. So if two angles are complementary to each other, and then you have another angle that's complementary to the same shared angle, those other two angles are complementary. Okay, so same idea with complementary. That's what theorem 2 3 says. 2 4, all right angles are congruent. Well, why is that? Because the measure of a right angle is 90 degrees, and anything with 90 degrees is congruent to anything else with 90 degrees. Okay, that obviously makes sense. Okay, if two angles are congruent and supplementary, then each is a right angle. Okay, two angles are congruent, so angle 1 is congruent to angle 2. Their measures are equal. Oops. Measure of angle 1 equals measure of angle 2. Okay, they're supplementary, then that means angle 1 plus angle 2 equals 180. Right? Okay, sorry, you should say measures. If we're putting equals, they should say measures. So let's just substitute measure of angle 1 in for measure of angle 2. Okay, we're doing a little mini proof here. Just to give you another example. Measure of angle 1 plus measure of angle 1 equals 180. Okay, 1 plus 1 gives me 2 measures of angle 1 equal 180. Now divide both sides by 2. Measure of angle 1 is 90. Okay, and since measure of angle 1 equals angle 2, measure of angle 2 is also 90 degrees. So there's another proof of the theorem. Each is a right angle. Okay? So the more you think about this, the more you do your homework, the easier these proofs will come, I promise. Alright? Turn to the front and write down the homework that's on the board for you. Go ahead and start it, and I hope you have a great rest of your day.